So the first thing we're going to talk about is how to find, okay, yesterday we talked about how to find distance between 2 points, correct?
Right.
Okay. What is a geometry topic that is associated with distance between 2 points? The midpoint. And Noah, how do you find the midpoint? Okay, midpoint means you are in the middle. And how do you find the middle of something? You average them, right? Average the x's, average the y's, average the z's. Okay, so much like the distance formula, the midpoint formula doesn't really look much different. There's just these in there. Okay? So we are going to find the midpoints between -419 and 2, -16. All right? What is the average of -4 and 2? -1. What's the average of 1 and -1?
0.
And what is the average between 9 and 6? 7.5. So 7.5, or you could write 15.5. Okay. Can you handle it? Okay. All right. We talked about conic sections in a plane. We are going to apply some of these conic sections in 3 dimensions. Okay? So a sphere, you're familiar with what a sphere is, correct? It's a 3-dimensional circle. Okay, so what are the properties of a circle? All the points are equidistant from the center. Okay? So here we have points equidistant from the center, but we're just in 3 dimensions, so we create a sphere. All right, here is the standard equation of a sphere. Okay, once again, it looks like that of a circle. There's just now the third coordinate for z. Okay, so HKJ is our center. R is still our radius. Notice how R is still squared. It is not cubed. Okay, we're still talking about So we are going to write the equation of a sphere with the center at 2, -4, 3, and a radius of 3. Okay? So, help me out. We have x minus 2, the quantity squared. That gives me the x coordinate of our center. Plus y plus 4 squared plus equals 9. Okay. Now, that was a very simple problem. Let's talk about other problems you could encounter in your homework. Okay? If they gave you the endpoints of the diameter.
You could take the midpoint from it.
Okay, first of all, both of what you said is right. First of all, we can find the midpoint, and that would be the center. How would you find the radius? Okay, you could either, if you found the midpoint first, you could find the distance from the midpoint to the end of the diameter. Or if you take the distance between the two diameter points, then you would have to cut it in half. Alright? Everyone's good with that? Yeah. Alright. You will also encounter problems such as this. Completing the square. We are all professionals at completing the square because we have done it so many times. Okay, however, this time we have to do it. So, first of all, we can look at this and know it's a sphere. Why? Okay, first of all, x, y, and z are all squared. They're positive, and they have the same coefficient, much like we did with the circle equation. Okay? Okay, so I'm going to group my x's together and our y's together and our z's together. And what should we do with that 8? Alright, so what completes the square here? We have to add 1. 9. Here.
4. 9. 9.
Okay.
6.
So we have x minus 1 squared plus y plus 2 squared plus okay. Now, what did it ask for though? Center and the radius. So our center is what?
1.
And our radius.
Radical 6.
Ooh, I didn't fool you at all. Radical 6. Okay? Now, that is what is going to be on your homework. Now, I do want to talk about what other shapes we have in 3 dimensions that are made up of our different conic sections. Okay? So the first thing I'm going to talk about is an ellipsoid. Okay?
Is that like a sphere with
It's a blimp.
Okay, so let's talk about what this is. Okay, this is the standard equation. Okay? We talk about these 3-dimensional figures by their traces. Okay? So we have like an XY trace, an XZ trace, and a YZ trace. So there's 3 different traces that kind of make up the overlay of our figure. Okay? So what 3 different planar conics are making this?
What, 3 different ones? Circle, an ellipse.
Okay, so let's look at this.
Parabolas, maybe.
If we didn't have the Z, if we were just in the XY plane, what would we have? We would have an ellipse. If we were just in the XZ plane, we would have an ellipse. If we were just in the YZ plane, we'd have an ellipse. So an ellipsoid is made up of ellipses.
Oh, You want to know what?
Like any.
Watermelon.
Yeah.
So when we graph these, like when I graph these with my calculus 2 kids, all right, we would draw these 3 ellipses, and then you could see this shape. Okay. Now let's talk about three-dimensional figures. We live in a three-dimensional world. What are ellipses? What have you seen? Or sorry, an ellipsoid. What ellipsoids have you seen in real life?
Limbs. Football.
Blimps. A football is an ellipsoid.
Not perfectly.
But they go. That's more rugby ball.
The lace is still
Okay, a rugby ball maybe would be a better fit, but an ellipsoid, a football is
a pill.
a pill?
Yeah.
Some pill.
Yeah. Okay, so you've seen lots of ellipses. Ellipsoids, excuse me.
I've also seen ellipses.
Okay, but really, that looks like a blip, right? You see blips when you watch football games.
I have no idea what it is. Oh, I know.
Okay, the next thing, we have 2 different kinds of paraboloids. Okay, so what kind do you think this deals with? Okay, so this one is an elliptic parabola. Okay. This is the standard equation where we have, okay, over here, this looks, kind of like an ellipse, right? But on the left side, we just have z. It's linear. Okay, so we have 2 variables that are positive, and they are quadratic. They're second degree. And on the other side of the equal sign, we have a linear. Our third variable is linear.
Just keep going.
Yeah. Yeah, this keeps going and going and going and going. We can restrict it to cut it off.
But it
right?
wouldn't
like
stop.
a parabola that's like rotated around 360.
Okay. Well, let's talk about it. Let's talk about the 3 different traces we can have. Okay, so if we start plugging values in for z, what kind of a shape are we getting? Like if z is 1.
Really small. Confused.
I am also confused.
If z over c is a constant, what kind of shape are we going to get?
It's just going to be a ellipse.
Thank you. It's going to be an ellipse, right?
Why there's ellipse?
Oh, which is why you see all these ellipses, right? Okay. Now, if we start, plugging things in for x, and our x's disappear, what do we have? We have a parabola, right? One of them squared, one not. Okay, so we have a parabola. If the y's disappear, we have
Also a parabola.
we also have a parabola. So this is made up of parabolas and ellipses. Okay? What does this look like? Kind of like a spherical. Yeah. It might be like wider parabolas would make a more efficient bowl.
Dunce cap.
Like a chalice, right? Like the top.
Yeah.
An umbrella.
A dunce cap.
If you turn it around, it's like those things that are at hair salons.
A thimble.
Okay, now, a lot of these things that you're describing wouldn't necessarily have ellipses. What would they have? They're more circular, right? Which is, it's still classified as an ellipse, so that's okay. All right. A watermelon, half of a watermelon. Number one's watermelon. Okay? The other kind of paraboloid is a hyperbolic paraboloid.
Gross. Get it away.
Oh, what kind of potato chip?
Pringle.
I thought Pringles.
I definitely see.
I see it's static.
She's got
Let's go in class.
This is my snack for later.
I can smell it.
Oh,
Oh,
I'm seeing it.
either way.
I'm seeing it.
you see that one story where that like girl?
In other words, you look really sick.
No, there's that one story where the girl's like.
Okay, so anyway, what different conic sections is this made up of?
Probably parabola and hyperbola.
Probably parabola and hyperbola. Okay? If we plug things in for z,
It's a hyperbola.
we have hyperbola, right? If we plug things in for x, we have a parabola, and if we plug things in for y, we get a parabola. And so we have two different traces of parabolas, and then a hyperbola making this look. Now this goes on forever, but when you restrict it, when you restrict the domain, okay?
I see the parabola.
How does it go on for?
Yeah.
Like out.
Does it go
Like,
Looks like a
Up?
skirt and like the very
down?
bottom.
Okay, down.
oh yeah,
Yeah, it was
skirt.
Yeah.
Oh, I see the scenario.
I do.
Yeah. Yeah, the heels high on the back.
Yeah.
All right, one more kind. A hyperboloid. There's
Oh.
two different kinds.
See what black
I love those things.
Okay? This is a hyperboloid of one sheet. This is a hyperboloid of two sheets.
What does that mean?
It's like just if it's connected.
Well, thank you. This is connected for one figure. This is disconnected, so there's two pieces. Okay? So the hyperboloid is made up of, let's look at it. The x's disappear, we have a hyperbola. So in the YZ, we have a bunch of hyperbolas parallel. Y's disappear, we have another hyperbola. So in the XZ plane, we have parallel hyperbolas. And then the Z's go away, and we have an ellipse. Okay, so these are all ellipses connecting those hyperbolas together.
The other one's negative.
Okay, yeah, what is the difference between the one sheet and the two sheets? Okay, why is -1? In other books, you might see this as a +1, and you just have two negative values over on the left side. Does that make sense? Okay, you're still going to get you're still going to have two different traces that are hyperbolas and one trace that's an ellipse. Okay? Now, these figures, other than a sphere, I will not test you on, okay? But I think these are really cool, alright? And I think exposing you to them, okay? What in real life looks like any of these?
Volcano that like blew up.
It's a
A
vortex.
drum? This looks like a drum?
Yeah.
It looks like a tornado. It's a vortex, like a whirlpool.
Okay.
Tornado.
That looks kind of like a portal. If you go on one side and out the other.
Yeah.
Portal.
Looks like two
Okay.
funnels.
One of those like
Portal.
Chinese
Like
yo-yo
Japanese,
fingers,
yeah.
you know, the
Oh,
two-
yeah.
Yeah, the hats are like, I don't know.
Okay.
Chinese.
If any of you go into like 3D graphics or anything like that, you may see these kinds of things. Okay? Alright, so anything that we talked about on these three slides, you will not be tested on. But look how cool these things are.
I like that one.
I don't like that one's ugly. I honestly.
The paraboloid's your favorite? Rainbow. Okay. Okay, here's your homework assignment. It's really about midpoint and spheres.
Can I borrow some?